So, friends, as I was telling you that I put a point on the board. So here is the point, and I will clean it from the board. Now it is back to nowhere. So can anybody come and put a point at the exactly same place where I have put? That was my discussion. I think nobody can do it, and that's my challenge. Nobody can put the point exactly at the place where I have done earlier. But if you know this coordinate geometry, this job can be very easily done. How it is done? We take the reference to this point. I take the edge of this board, vertical line, and this as the horizontal line, and then I measure where this point was put. I measure on the horizontal direction. Suppose this measure is like this, and in the vertical direction it is something like this, and I draw a parallel line to the board. This is the vertical line I have drawn parallel. This is the horizontal line I draw parallel to the board. Right. Now I can draw the projection. So you see, I have got a reference of two lines. This is the horizontal line which was parallel to the edge of the board. This is the vertical line which was parallel to the vertical line of the board. And they are intersecting at a point called O, or we normally name it as origin. Now this will be called the x-axis, and this will be called the y-axis. So these two axes are mutually at 90 degree, because this end was 90 degree, a rectangular piece of board. So when it is 90 degree, these two lines are also perpendicular to each other. And now I have drawn projection from the point P onto the x-axis and onto the y-axis. Projection means line, imaginary line, which is also perpendicular to this axis, and this is also perpendicular to the y-axis. Now I measure this distance. Suppose this distance is x1, because it is on the x direction. From here to here, this measurement is called x1, and from here to here, this measurement is called y1. So now I can define this point as a coordinate of x1 comma y1. As there are two values without which P point cannot be reached. Just look at again. I start from O, move x1 distance along the x-axis or along the horizontal line of the base board, and then in a right angle triangle or right angle direction 90 degree, I move another distance y1. Y1 I move along the y direction. This is not x1. This is x1. This is y1. Then this x1 and y1 put together, I reach at this point. This was x1, and from here I rose y1. Y1 is parallel. So these 2 points will define point P as a location on the whole whiteboard. And this, if I give a numerical number, say 3 and 4, I name this point as 3 and 4. Then 3 units on this direction, 4 units in this direction, and definitely you will come only at a point P. You cannot reach anywhere else. You cannot go to this point or this point or this point or this point. So that is what is the exact location of the point P if I know the coordinate. Why they are called coordinate? Because they are two values put together. Without these two values, I can't reach P. That is why the name coordinate has come. Geometry means it is drawn with points and lines. Sometimes it will be curve as well. So it is geometry. So you understood how to locate a point P with the coordinate geometry. Now suppose we have this point only here. I clean it and give you another example. Suppose we have a point P here and a point Q here, right? Now this P point is denoted as x1, comma y1, and Q is denoted as x2, comma y2. And if somebody asks you, find the distance between P and Q without measuring, how we will do it? We can do it with coordinate geometry, right? So I tell you the process of doing that. You draw again some imaginary line perpendicular from P on the x-axis, let us call it as Pn, and let me draw the axis line properly. And let Q be QR, and let this be M. These are all 90 degrees because I have drawn a perpendicular from point P on the x-axis, perpendicular from point Q on the x-axis, again a perpendicular from P on the line QR. You understood this? So I created a right angle triangle which is called PQM. Now the triangle PQM is a right angle triangle with a right angle at the point M. Angle M is 90 degrees. So by Pythagoras theorem, what we know in a right angle triangle, if this is the hypotenuse, this is the perpendicular, and this is the base, then the hypotenuse square is equal to perpendicular square plus base square. That is the Pythagoras theorem. We write it by Pythagoras theorem. So only h I require. So what I'll do? I'll make a square root of the whole thing. So when I do the square root, this will become h and this remains as it is. So p square plus b square. Now what is p? P is this much, q to m. And to write the qm, what we need is, qm is from q to r the whole distance, subtract mr. So qr minus mr. Now qr is the y value of the point q, which is assumed to be y2. So y2 minus mr. mr is nothing but pn. So we write y1. Similarly, when I find out base is called pm, and pm is equal to nr because this is a square. So pm is equal to nr, and nr is nothing but or minus on. Or minus on, and or is the x value for the point q, on is the x value for point p. So this becomes x2 minus x1. When you put back these values of qm and pm here, which is called, qm is basically called the p and this is called the b, these values you put here, then the distance h, which is equal to PQ distance, is equal to under root of y2 minus y1 whole square plus x2 minus x1 whole square, whole under root. So this is the simple formula, and this is denoted as d is equal to root over difference of either x2 minus x1 whole square or maybe y2 minus y1 whole square. You can write either way because both are whole square and they will be positive. So no problem if I write this in front, this afterwards, or if I write this before this. I think this is clear to everybody. We will talk about some more formulas in the next session.